In this video, I'm going to show you how to do factoring by a method called grouping. And I want to just quickly review the two that we've already done so far. So the first kind of factoring that we've done is called GCF. And what that stands for is greatest common factor. And this you always do first. So look at all the terms in your polynomial and see if there's anything in common that you can take out from every single term, and that would be your GCF. It would be the highest factor, number factor that you can divide out, and then from the letters that you see, it would be the smallest power. Now we've done one trinomial version so far, and it's when a equals 1. So real quickly, just a couple sections that we did. GCF, so between two terms here. We did videos on that before. And then when a equals 1, so two numbers that multiply to make the last number, add to make the middle number. But now with grouping, I have here to let you know that grouping goes here. And this is when you see 4 terms. And so what you're going to do is take the GCF of the first 2 terms and the GCF of the last 2 terms, and then you're going to see your factors are the same, and then I'm going to put a factor here, and I'll show you what that looks like. So notice how I have 4 terms now in each of these examples, and my directions here say factor by grouping, group into 2 binomials using parentheses. Now I don't use parentheses, I'll show you how I do this, but we're going to take the GCF of each group. So in the first 2 terms alone, just those first 2 terms, what do they both have in common? Well, this is 1x squared and this is 1x cubed, excuse me, and 2x squared. They both have x's in common. In fact, the amount that I can take out of both is the smaller of the power, so x squared. Now if I take out x squared from x cubed, I'm left with 1x. And if I take the x squared away from the 2x squared, I'm left with a 2. So that's just the GCF of the first 2 terms. Now the last 2 terms, we're going to also take out the GCF. And each of these 2 terms is divisible by a positive 3. So 3x divided by 3 is x, 6 divided by 3 is 2. And now watch what happens. When these 2 factors are identical, when they match exactly, my pen's not working. So I should say when this match, that means that grouping worked, and that's going to actually be one of your factor answers. The GCFs that you pulled out, the x squared here and the positive 3, they come together to make your other factor. It's pretty cool how that works. So anyway, I'll try and show you 3 more examples in this video. And so again, you're going to find the GCF of your first 2 terms. So in the first 2 terms here, they both have x's in common, so we're going to take that x squared away from both of them. So I'm left with 1x here, and if I take the x's away, I'm left with a 4 here. And now again, the GCF, both of these 2 terms are divisible by a positive 6. So if I divide by 6, I have the x left over. 24 divided by 6 is 4. Now when these 2, excuse my dog sneezing in the background, when these 2 match, that means grouping worked. Excuse you, Stella. And this is one of your factor answers. You don't write it twice, you only write it once. And the reason is because it's kind of like distribution. You pull this out, there's only one of those factors, but then your GCFs come together to make the other factor. Now I want to show you how this works. I'm going to distribute and multiply here to show you that we get our original answer. So here's my check. Watch. If I take x times x squared, I get x cubed. If I take x times 6, I get 6x. And if I take 4 times x squared, I get 4x squared. And if I take 4 times 6, I get 24. Notice how all these terms are the same, they're just in a little different order, but I still have the same polynomial if I rewrite this in standard form. And this is exactly what we had in the beginning. So I know that this was my answer because I multiplied to double check. And so if you're not sure if you factored correctly, you can always multiply to make sure that you got the same polynomial that you started with. Okay, so let's keep going here. I'm going to take in this next example here, the GCF out of the first two terms, which also happens to be x squared. Seems to be a common thing to pull out in the first two terms. So I'm left with 1x and a positive 3. Now I notice my next two terms are both negative, so I'm going to take that negative away. Plus I want to see this factor match. And if these are both negatives and these are positives, if I can take that negative out, my matching factors should hopefully be positive. So I'm going to divide by negative 2. Negative 2 divided by negative 2 is positive 1x. Negative 6 divided by negative 2 is positive 3. Now again, when these match, that means that was one of your factor answers. And the GCF that you saw, that you pulled out, those two come together in the same order that you took them out. So this goes first, and this goes second, and that's your factor pair. It's pretty cool. All right, here is one more example for this video. And these two terms, they have in common the smaller of the power, so x cubed this time. So if I had a 4 and I take away x cubed, I'm left with an x. Negative 3x cubed, and I take the x cubed away, I'm left with minus 3. And now in my next two terms, my GCF is the number 4. Those both terms are divisible by 4. So 4x divided by the 4, I have my x left over. Negative 12 divided by 4 is negative 3. Now again, when these match, that is one of your factor answers. And the GCF that you took out and the other GCF that you took out come together to make your other factor pair.